My dear students, today I am going to teach you third part of 12th class relation and functions. Functions are very important topic from this chapter point of view. My dear students, functions are of many types. First type, 1 that is called injection. First type of function is 1 function. 1 function means a function f such that x tends to y is said to be 1 if the images of distinct element of x under f are distinct. That is, this is the condition for 1. For every x1, x2 belongs to x, fx1 is equal to fx2. This implies x1 is equal to x2. Condition for 1. Now I want to make it clear that 1 function is, in this function there are two sets x and y. If all the distinct element of x have distinct images in y, then it is called 1 function. With the help of example, I want to make it clear. I am taking an example. X, this is y. Element of x, 1, 2, 3, 4. Element of y, a, b, c and d. If every element of x have distinct images in b, in y, then it is called 1 function. One element of x1 have has a image a in y. Element 2 has a image b. Element 3 has a distinct image c. Element 4 has distinct image d in y. One image of 1 is a, image of 2 is b, image of 3 is c, image 4 of d. All the distinct element of x have different images in y. This function is called 1. And condition is x1, x2 belongs to x, fx1 is equal to fx2. This implies x1 is equal to x. This is the condition for proving any function, whether it is 1 or not. This is the condition. Remember it. I am taking another example. In this y set, a, b, c, d, e and f. Now there are two sets x and y. X has 4 distinct elements and y has 6 elements. One has image a, image of 1 is a, image of 2 is b, image of 3 is c, image of 4 is d. But these two elements of y have no pre-images in x. So but the condition is that all the element of x have images in y. There is there are two elements c and f in y. have no pre-images. This is not a matter. In one condition, in X, all the elements should have image in Y. This is the condition of 1 1. And a second function, onto function, onto function. A function, a function f such that X tends to Y is said to be onto if all the elements of Y is a all the elements of Y is a pre-image. Yeah, is a image of distinct element in X. Here I want to again make it clear to you that in onto every element of Y should have a pre-image in X. Understand my point? In 1 1, every element of X has pre has have images in Y, and every element of Y, if have pre-images in X, then onto. In 1 1, we should consider X. In onto, we should consider Y. In 1 1, all the elements should have a image in Y. In onto, all the elements of Y should have pre-image in X. These are the two functions. I think you have understood my point. And the condition is that if Y belongs to Y, any element, any arbitrary element, Y belongs to Y, then Y is a image of some element in X. This implies that fx is equal to y. This is the condition of onto. Condition of onto. Condition of onto. Fx is equal to y. So my dear students, these two functions are very important from examination point of view. 1 1 function and onto function. I think you have understood the 1 1 and onto. Again I am going to repeat 1 1 function. In 1 1 function, listen to me very carefully. In 1 1 function, we have to take seriously X. If all the elements of X have images in Y, understand this word, all the element of X have images in Y, then it is onto. If all the elements of Y have pre-images in X, then it is onto. In 1 1, all the element of X should be covered under the images. And in onto, all the elements of Y should be covered under the images. This is the condition. Now I am going to take some example from the book. With the help of example, I want to make it more clear. Example. First example. One more function I want to tell you. One more. Third. 1 1 and on to, or 1 1 and on to. 1 1 on to means if function if a function f x tends to y is 1 1 and f such that x tends to y is on to, then function f x tends to y is 1 1 and on to. This is the combination of two, 1 1 and on to. If a function is 1 1 and that the same function is on to, that function will be 1 1 and on to. So this is the combination of these first two functions, 1 1 and on to. So I am taking example. Let a example first. Example first. Let A be the set of all 50 students. Let A be the set of all 50 students of class 12th in a school. Let A, let function f A tends to n. This is the function. You have to see this function very carefully. In set A, all the elements of A you have to consider. In set B, this is a set of natural number. In this set, all the natural numbers will lie. B function defined, B function defined by fx is equal to roll number of the student, roll numbers of the students. X. So that f is 112, so that f is 112, 11, but not onto. F is 11 but not onto. We have to prove that. Here, one thing. There are two sets A and B. In A sets, there are 50 students. And in N, all the roll number is 50 students. It has one roll number. It means 50 student has 50 roll numbers. But in N, there are so many natural numbers. But in A, all 50 students. So, A and N set. This is A, this is N. 50 students, 1, 2, 3, 50. 1, 2, 3, infinity. Or take here 50 and so on up to infinity. This is the question. In A set, there are 50 students. In N set, all the natural numbers. And these students contain their roll number in N. Here, first student has roll number first. Second roll number. Third student has third roll number. In the same way, 50 student has up to 50 numbers, their roll numbers. Here the student first, roll number first, student second, roll number second, student third, roll number third. In this way, student 50, roll number 50. But in this N, there are so many numbers other than 50 and above 50. This set contains all the natural numbers and this set contains only 50. But one thing I want to tell you, first student has first roll number, second student has second roll number, third student has third roll number, and 50 student says 50th roll number. And all the roll numbers of 50 students have covered. Here you see that all 50 students, all 50 distinct students have distinct roll number in N. This means all the students of A have their roll numbers, distinct roll number in N. So this is a 1 function. This proves that this is a 1 function. Because I have told you that all the elements of X should have images in N. So 50 student and 50 roll numbers, 1:1 have their images. All the elements of A have covered. So this is the condition of 1:1. But now for on to what is the condition for on to? All the element of N should be covered and should have pre-images in A. But in N, only 50 students have pre-images in A, and above than 50 have no images in A. So the second condition, any condition of onto, is not fulfilled because all the elements have no pre-images in A. These all students have their images in N. This is so therefore this is 1:1. But all numbers of N have no pre-images in A, so therefore it is not onto. I have told you that in 1:1 all the elements should be covered. In onto, all the elements of N should be covered under image, under the F image or pre-image. This is the condition. So this example is 1 1, for this is a example of 1 1 function, but here this is not a, this example shows that this function is not onto. Now I am going to take another example. So that the function, example second, so that the function, so that the function f such that n tends to n. I think you have understood that both the sets are of natural number. Here, this is very important. Given by fx is equal to 2x is 1 1, is 1 1, no, but a not onto. Here, we have to apply the condition which I have told you, that x1 and x2 belongs to x, therefore fx1 is equal to fx2. This implies x1 is equal to x2. Here, fx is equal to 2x, fx1 is equal to 2x1, first fx2 is equal to 2x2, second, by first and second, fx1 is equal to fx2. This implies x1 is equal to x2. Our condition is fulfilled. Our condition of 1 1 function is fulfilled. So therefore this is a 1 1 function. 1 1 function. Now second, we have to prove that this is not onto. This, take fx is equal to 2x and fx is equal to y is equal to 2x, and take two sets with the help of sets n and n under f. Now put x is equal to 1, x is equal to 1 here, y is equal to 2 into 1, y is equal to 2, here 2, y is equal to 2x and y is equal to, when x is equal to 2, y is equal to 4, when x is equal to 2 and x is equal to 1, take, then 2 and 4. In the same way, 3, 6, 4, 8, you will get the values in the same way. Here you see that this is a natural function, natural set. All the elements 1, 2, 3, 4. And this is also a natural number set. Here, natural number set, according to this function, these are the element of this function. These are the images of this, yeah, you can say the pre-image of 2 is 1, pre-image of 4 is 2, pre-image of 6 is 3, pre-image of 4 is 8 is 4. But This set contains other natural number also. Here 1 has no image, has no image. Here 3 has no image, pre-image. Here 5 has no pre-image. Here 7 has no pre-image. Understand my point? These numbers have images. Or you can say that 2, 4, 6, 8 have pre-images in X. But 1, 3, 5, 7 and other numbers have no pre-images in N. And condition of 1, 2. I have told you that all the element of N should have pre-image. All the element of N, listen to me very carefully, for on to, all the element of N should have pre-image in N. But some element have pre-image in N, some element do not have pre-image in N. Therefore, this implies that this is not onto function. I am taking one example more so that this concept will be clear to you, because this concept is very important from the examination point of view. You will get one question 100%. You have to prove that this function is 1 1, or this function is on 2, or this function is both 1 1 and on 2. This will be a question and you will get one question. So I am taking one example more. Prove that. Example third. Example third. Prove that. Prove that the function. Prove that the function f such that r tends to r. I am against making you alert. Here the function is r to r. In the second example, function was n to n. In that case, both the sets have natural numbers, but in R to R, these two sets have real numbers. This is the difference. These two sets have real numbers, and real numbers are all numbers. Real numbers contain natural number, real number contains whole numbers, real number contains integers, real number is a combination of rational and irrational. It means real numbers are all numbers of mathematics are real numbers. Yeah, all the numbers of number line are called real numbers. So these two sets have all the numbers. And given by, but very interesting question, given by fx is equal to 2x. The function is same here. Now we will prove if x1, x2 belongs to x, then x1, x2 belongs to x, or then fx1 is equal to 2x1, fx2 is equal to 2x2. This implies first and second, fx1 is equal to fx2, fx1 x1 is equal to x2. Condition of 1 1 is fulfilled. Fx is equal to 2x. The condition of 1 1 is fx1 is equal to fx2. So fx1 is 2x1, fx2 is equal to 2x1 by putting the value here x x1 in place of x and x2 in place of x. There are two equations. You will get two equations. By comparing these two equations, you will get fx1 is equal to fx2 and x1 is equal to x2. It means this function is 1 1. Very interesting question. This function is 1 1 according to the condition of 1 1 function. Now I am going to test whether this function is onto or not, because the sets are real numbers, because the sets are of real numbers. Here fx is equal to 2x. It means y is equal to 2x. First set, second set, this is R under f. Now x is equal to 1, x is equal to 1, 2 into 1, y is equal to 2, y is equal to 2, y is equal to 2x again, y is equal to, put x is equal to 2, 2 into 2, y is equal to 4, x is equal to 2 and y is equal to 4, and x is equal to 3, y is equal to 6, x is equal to 4, y is equal to 8 in this way. Go on. Now one thing I want to tell you here, here there are all numbers, but here 1, consider this 1. If you put the value of y1, you will get the value of x1 by 2. If you will put the value of 3, take this number, you will get 3 by 2. If you put the value of y5, you will get the value of x is equal to 5 by 2. These. It means if you take all these numbers between these 1, 2, 4, 1, 3, 1, 2, 4, 6, 8. The numbers are 1, 3, 5, 7. If we put the value of a y 1, 3, 5, 7, the pre-images will be 1 by 2, 3 by 2, 5 by 2 and 7 by 2. But this is a real set. This is the set of real numbers. These are the real numbers, the rational number. 1 by 2. What is 1 by 2? Rational. So belongs to R. What is this? 3 by 2. This is a rational. Belong to R. What is this? 5 by 2 belongs to R. What is 7 by 2 belongs to R. It means if you put any value, either 1, 2, 3, 1 by 2, 1 by 3, 1 by 4, any value, you will get the value in real form, and both these sets are real. Either here you can take any value, and here you have any value. So for onto this function is fully satisfied. So this implies that this is onto function. This is onto function also. 1 1 also, onto also, because all the element of R, second set, have the pre-images in R, first set. So condition of onto is fully satisfied. So this function is 1 1 and onto. My dear students, I have taken many examples of this 1 1 and onto function. I think you have understood, and in fourth part I will take more function. So this third part is very important from the examination point of view. You will get one question from this. So I want to make a request to you. Please do all the question of NCERT, and also subscribe this channel also. This is my request to you. Thank you, my dear students.